Hello and welcome to the FlowCAD webinar. My name is Petra and I'm supporting my colleague Rolf Nick, who will show you how FloWare can help you and increase productivity in PCB design. If you have ever had contact with our support or attended a training, you probably already know Rolf. Some words about him. He studied communications engineering and has many years of experience in PCB design and simulation. Rolf is responsible for FloWare product development. The webinar will be recorded and provided to you afterwards. Our cameras will remain off to avoid technical problems as far as possible. Questions will be answered at the end of the webinar. Please just write them into the chat. If time is too short, we will respond by email. That's all for the moment. So, Rolf, let's get started.
Okay, thank you very much, Peter. So let's give me a short introduction about FloWare, and I guess that some of you already use some FloWare modules. FloWare are general purpose utilities which cover functions which are probably not in the standard tool yet. So they stem from discussions with customers in the pre-sale situations, or even with customers from hotline or who are in maintenance. So asking for a certain type of features, and as soon as we realize that several customers are asking, or multiple customers are asking for some features, we careful. We take the initiative and investigate how can we help the customer. Of course, we discuss with Cadence, and we ask for development schedules and plans. But Cadence is a huge EDA company. We all know that, and development resources may be limited. That's why we try to provide a solution to the customer rather than saying, yeah, okay, we have communicated this with Cadence and now we wait until this gets implemented. So fortunately, FloWare or PCB editor, Allego, Cadence provides an automation layer which is called Skill, which allows us to do any kind of automation, right? So it is primarily used for customization, and it can not only extract data and can for generating, for example, a BOM report. It can also be used to manipulate the database. So Skill is the automation layer. It is dedicated for automation, for customization, for data manipulation, and even it makes some time to get familiar with it. It allows you to interact in terms of developing applications which are fully interactive, including a user interface, including customer interactions like, window drag, user pick, oops, and canceling. So the purpose, our motivation is when we develop a module for FloWare, make it behave like a standard command and make it as smooth as possible. And this also includes the ability to, also includes documentation. So each module has a full documentation included. So as I mentioned, so Skill is the automation layer under the hood, and it allows you to write almost everything. And just to get a little bit familiar, I would like to make you curious about Skill. If you have some familiarity with programming, and it's actually only the question how to start. How can I write my first program? And this is fairly simple. So not every customer knows that there is a skill interpreter window available which allows you to communicate with a database. So simply enter set tel skill in the command line of Allego of PCB editor. By the way, the skill interpreter window, sometimes I refer to Allego, but this also applies to OrCAD PCB Designer Professional and upwards. In OrCAD PCB Designer Standard, you will not have the skill interpreter window. You can still just, let's say, execute existing code. But I guess most of the customers have at least OrCAD PCB Designer Professional, which includes the skill interpreter window. So as I mentioned, simply enter that command here, and then you get this window here. I will show that later in the demo, of course. And what you do, what is the first command you will enter? Of course, is printf hello world, we know from Koenig and Ritchie. But then that's not everything. You can define variables, a equals 3, b equals 4. You can do mathematical operations. You can even extract now data from the from the PCB editor database, for example, information about nets in the database, information about layers, information about pad stacks, about symbols. Yes, of course, the skill interpreter window is primarily dedicated to for testing certain commands, how to work with if they work, and what kind of information you get extract out of the database. In the end, you will primarily use a text editor to write your skill program. So when it comes to accessing the database itself in terms of logic, part list, nets, physical data like traces and cross-section, you will need you need to know, okay, what are the APIs, what are the skill procedures I can use to extract those. So they are part of the installation under share PCB example skill doc funcs. Sorry, you don't need to remember the exact path. You will even find it in the documentation itself. So I usually refer to this folder here, and I do a simple filter. For example, if I want to check, okay, what kind of APIs are available to check if a layer is visible or not, I simply search for a layer, and then you get a couple of APIs, and then it's even if you look at the name of such an API, Axle is visible layer, I think it's quite obvious what this skill procedure does. Yeah, it simply checks whether a layer is visible or not, right? And using these resources or simple examples, you can extend your skills by simply testing, writing, checking. Yeah? So as long as you are curious, you will get familiar as fast as possible. This is, let's say, the skill which is under the hood. And another benefit of skill is that it is completely platform independent. So it's fully integrated into the Cadence installation. So that means there is no compiling necessary. You don't need to pay attention to any platform dependencies. So when it comes to accessing files directory or creating new files, creating directories, simply use the APIs which are provided by skill. They take care of the underlying operating system. Also, you don't need to worry about if you use backslash or forward slash in your passes. In skill, everything can be expressed using forward slashes. So no need to worry about, oh, am I on Windows or am I on Linux? It doesn't really matter, because, as I mentioned, skill takes care of it. Completely platform independent. That is a big benefit. So, and now this is a full list of FloWare modules which are available until now, and I don't want, so no panic, so I don't want to discuss them in all in every detail. Just I just want to highlight a few latest additions or enhancements we have made to existing applications. So let's start with the anti-tamper mesh PCB. This is an application, seems to be a special application, but for hardware security modules, for example, they often require a convoluted mesh of wires on the outer layers of the PCB. So the main purpose is to actively detect and respond to external attack by monitoring changes in resistance, capacitance, breaks, or even shorts. So the trace mesh, as you can see here in the screenshot, can be designed as a network of conductive traces on the PCB that encircles or covers sensitive areas. And if someone attempts to access or tamper with a device, they would have to break these traces, which can trigger a tamper response. So again, the main purpose here is to deter potential attackers. So, and what does the application help you? It helps you just, so we cannot help you with all your IP concerns, but we can only help you, let's say, generating such a trace mesh on the PCB by providing the ability to specify the layer on which you want to generate it, the number of signals. So these traces here, in this example here, we are talking about 3 signal loops. They start at this design here, at this IC here at U1, and they will also end here, right? And but it fully encircles, or it fully covers the open space in your PCB. So you can specify the line width, the spacing, origins, and some algorithm-related options. So this is anti-tamper mesh PCB. Of course, I would like to demo this later. So I'm switching back now to the table of contents. Next one is AOI checking. So AOI is a widely used technique in PCB. manufacturing that leverages advanced imaging technology to inspect printed circuit boards for defects, especially after the solder process. So it's insufficient solder joints or high defects, solder bridging, excessive solder joints, thumb stoning, etc., just to name a few. They need to be carefully checked. So there's a camera involved, and the camera has a predefined angle. And now the situation can occur that tall components with a given height may create shadow, and shadow, let's say, so that adjacent pads or pads nearby from other components, from adjacent components, will be shadowed. In other words, the camera cannot properly check those pads, right? And this is the main purpose now of these applications, to help customers checking for those kinds of AOI-related issues that can occur. And the biggest benefit of this application is that it allows you to generate the shadow areas. This is really useful for floor planning purposes. So you will see it here in the screenshot. X100 is a tall component. Based on its height, component height, and based on the camera angle, the shadow can be calculated in whatever direction. I will. This is discussed in the next slide. And any pad from an adjacent component like R205 in this example here, which is now partially covered by this shadow, it will generate a DRC. And the only thing you need to do right now in the floor planning phase is to grab these components and move it away. So this is the benefit of AOI checking. And here, when it comes to shadow generation, so the default parameter, the direction is set to all. That means we generate the shadow in all directions. But if necessary, if you want to take into account the conveyor belt direction, you can even specify the shadow to be generated only in the horizontal direction or in the vertical direction, or even by specifying a certain amount of a certain angle. So if you're not sure what the conveyor belt direction is for your board, so set the value to all, right? And also the camera angle matters. So the smaller the camera angle, the smaller the shadow will be. I will show this in the demo later. This is AOI check. Next one is contour place. I guess you're all familiar with the contour routing in PCB editor. So you can route one trace or multiple traces and hug them and align them according to an adjacent contour, follow them a certain contour with a given distance, like the root keep in, for example. And sometimes also the situation occurs that customers are asking for contour placement. So you have an arbitrary path and you would like to place the components on this contour and align them accordingly by locking short side or by locking the long side. You may even want to create those snap markers interactively. Contour placement, an application which is useful for, as the name already implies, for contour related placement. Next one is a bigger one, sorry. Digital solder masks. We may also refer to it as additive solder mask techniques. Sorry, I got. So in the past, everything was driven, or solder mask generation was driven by a negative process. So we simply flew the whole PCB, and only in those areas, pins, for example, or vias, where we don't want to have solder masks, we define an open region. But today's application requires more control for solder mask generation. So rather than simply fluting the whole layer in a negative way, we try to think positive. So we want to partially add solder mask, and we may want to save, for example, material waste. And last but not least, solder mask now seems to get more and more important when it comes to provide additional isolation. Of course, then the thickness needs to be controlled carefully. So digital solder mask is an application which has been developed together with Word, which is a big PCB manufacturer here in Germany. And there are various techniques available to cope with additive solder mask techniques. So, for example, you may decide to start with a component boundary, or generate a solder mask only in the region of a component by acting or by deriving or taking into account this information from the place bound, for example. Of course, the amount of gap being generated between the pad and the solder mask can be specified also in terms of years. You may want to decide to create a solder mask region by simply dragging a region somewhere on your board. This is perhaps the most simple method. Or alternatively, it is possible to think about, okay, we only want to generate pad boxes or even run it in the trace mode. So again, it's about material saving. It's about providing additional isolations. So not only you can generate now a solder mask on just one layer, like the solder mask top or solder mask bottom, it will be also possible to generate solder mask on your own layers. You may have multiple layers in your cross section, for example, in order to provide a better isolation. Digital solder mask. So next one is also a new one. It's called NetMin Gap, and this application primarily applies to applications where, I don't know, high voltage nets are involved. So where customers need to carefully check if all the distances and clearances are maintained. They may want to measure for review and checking purposes, for compliance reasons. They may want to measure the distances on the PCB. This sounds trivial at a first glance, but we all know in PCB editor, when you do a display measure, you can only select physical objects like a pin, like a via, like a trace, like a shape. Yes, and of course you can measure between trace and via. You can measure between trace and shape between shape and shape, but you cannot measure between two nets. And if you are interested in what is the smallest value between two nets, you have to measure all the combinations and then filter them somehow in an external application in order to get the smallest gap. Of course, it might be possible to adjust the spacing rules in Constraint Manager until the first DRC gets generated. But this is time consuming. This is awkward, and usually you don't want to change the constraints, right? So NetMin Gap is an application, especially for those kinds of review-related purposes. And you have the ability to select multiple nets. You can filter by spacing class, including wildcards, of course. You can restrict the measurement to certain layers. So usually you may not be interested on distances on the inner layer, but only on outer layers. And you can specify, for example, the layer to be outer or top or bottom only, or only inner signals or only inner plane layers. You may be interested to know the n smallest gap. So you would like to report the first five smallest values for any net combination you have measured. The application is really fast. Even if you load in a huge board with hundreds of nets, it's not a big issue. So the underlying measuring mechanism is really fast. So NetMin Gap, this is something I would like to show you as well. Again, it was driven by 2 or 3 customers right now here, and they were heavily asking for that kind of feature. And as I mentioned, so I want to emphasize it again. So we are taking the initiative. So if a customer is asking, and if we see more than one customer is asking, we take the initiative and we develop. And then we offer it to the customer. Do you want to have it? And usually they then want to have it and they pay a small amount of money for it. And if not, okay. But usually we always discuss them with the customers, and and in most cases they are already they are happy, right? They will be happy and they say, that makes sense. Well, what we have developed here. So next one is now I'm talking a little bit about some enhancements we have made to the existing applications. And the first one is variant assembly. I guess some of you already have variant assembly installed and use that application. I don't want to. This is an overview about this module. This is nothing new. But what have we done here? So remember, when it comes to the view generation for top and bottom view, the capabilities were somewhat have been a little bit limited. So the top view was always, so the position was fixed. It's a location of the original board, and it was only possible to mirror the bottom view, either on the right side, left side, to north, to top, or to bottom, with a given distance. Yes, you can mirror it, but this lacks, at least the biggest issue was that it lacks the capability of scaling the views. So this is what we have implemented right now. Now you can scale the views to any arbitrary value, and this is useful, especially in small boards. If you have a small sensor board, but you would like to generate an assembly drawing in an A4 or even A3 frame, you might want to scale it, but still leveraging the existing functionality like crossing or coloring DNI components. This is, and last but not least, so scaling is supported, and of course this means that you must be also, it must be also possible to place those views at arbitrary locations. So this is a big enhancement we have made. We have also made some enhancement to secondary component annotation, but this is shown here, giving the customer some more capability here. But as I mentioned, the main purpose or the biggest benefit is scaling and arbitrary positioning of variant assembly views in the frame drawing. What else about panelization? I don't know if you may be aware that panelization is already also part of a standard tool like OrCAD PCB Designer Professional and even Allego. It's the same code. Cadence offers the many FloWare modules as part of the Allego Productivity Toolbox. They may even decide to integrate some of the modules into the base installation, which is the case for OrCAD PCB Designer Professional and higher. But customers, for example, in standard, using OrCAD PCB Designer Standard, they do not have panelization. They may use FloWare instead. Under the hood, just to remember for you, it's always the same code. And what have we done here? So you remember the current limitation. Say you have opened a board database, or your single board, and then you're launching manufacturer fab panelization. Then you get an error, and application is telling you, hey, a starter panel database must not exclude any part logic, NAD logic. You should start with a board containing only 2 layers. It must contain a board outline and a root keep in and a root keep out, and then you can open that database and start creating the panel from this panel starter base. This was a little bit awkward and confusing customers. What we have done now is that we are still launching this information, this pop-up confirmer, but then you have the ability to decide, do you want to create a new panel from this existing database? You may decide to generate a new panel from scratch by specifying width and height and edge clearance, or to use an existing panel template, including some, additional fiducials and predefined other mechanical symbols in the panel. And then you also have the ability to already export the technology from the existing board and load it into the panel. So that the step of setting up a panel has been significantly reduced. So this is something I will show you in the demo. So far, this is the overview. This is also shipped with the FloWare installation, FloWare overview. But of course, when you're on the tool, a detailed documentation is also available. So I'm now switching to the live presentation. And the only thing you need to enter is TBX help, for example. TBX stands for Toolbox. As you know, almost everything is included in Allego Productivity Toolbox. And here, the most convenient command to get access to complete documentation is to enter TBX help. So simply enter this command, and now you're getting an HTML browser opens, and then you may click, for example, okay, I might be interested in NetMingApp. Or even if you're just using, let's say, 1 or 2 modules of FloWare, and you would like to, I don't know, you're curious, you would like to know, okay, what does CAF DRC mean? What does class designer mean? What does call designer mean? Simply click on such a hyperlink, and then the related productivity or the related application-related documentation pops up. It's a small PDF document with usually in the range of 10 pages. With a lot of pictures, we try to make it as simple as possible so that you don't need to rate too much. Simply pay attention to the pictures. I hope they're easy enough to understand. So this is tbxhelp. Remember that command. This is especially useful when it comes to applications like, for example, edit anti-temper mesh PCB. Here in the options panel, you do not see any help button because PCB editor doesn't have any help button here in the options panel either, right? But if you're interested, yeah, again, you can launch the overview, as I mentioned. This is just the overview, or you enter tbxhelp and you will get all the information, the detailed information. So as I mentioned, how do we work with skill before I go into the live demonstration of some modules? As I mentioned, set, tell, skill. This is all you have to do. And now you have a skill interpreter window, and you can, you can enter your commands. So be curious. So for example, printf. This is a like hello world. Hello world. And now application returns hello world. So no compiling is necessary. So you don't need to build a, I don't know, compiling executable or what else. It's not necessary. If you want to make it more UI driven, you can say Excel UI confirm. Hello world. Now we have a pop-up confirmer saying hello world, and now you can press OK, and we are back in the skill interpreter window, right? There are even APIs available, like, I don't know, you want to, during your pick and place extraction, you want to make a decision and ask the user, do you want to do this or that? Excel UI, ask yes, no, and yeah, you have the ability to make a conditional branching. So you can define variables, a equals 3, b equals 4, yeah, and then you say c equals a times b, and you will get the result. So you can play with your commands. So now, how do I interact with the database? So say, for example, I would like to know how many nets do we have. So we can say netlist, I put it into a variable, nl is equals Excel db-get design. And this is really a very useful API. It gives you the root DB ID of the Allego database, of the PCB editor database. And now I can ask for nets, right? And now I have a netlist, and I can say length netlist. And it's telling me that this design here, without going into a report, diving into any report, I can simply extract now that this design has 480 nets defined. So the first nets, for example, is car NL, and I ask for the net name and say, okay, the first nets in this net list is a net called DDR3_MDQ7, right? And so this is, I highly appreciate having this API or this skill interpreter window, because it allows you to test a few commands. So now when it comes to more complex commands, you will switch to a text editor. And here I have made this a very, very simple procedure. I call this procedure my PMP, my pick and place. And here you see now how easy it is to create a simple report file. I define a name, my pick and place dot text to be generated. I open a port, then I'm printing some header into that port, and now we see this is the actual code for each component in the design. Excel db-get design error operator components. Here in the previous example, we have used nets, but we can also ask for components. I want to report comp name, comp symbol name, and comp symbol XY, the location. Right. This %L here, for example, is very, very useful. You don't need to worry about any variable typing, right? %L can print everything. So it means doesn't matter if it's a string, an integer, a float, or a Boolean variable. It simply prints everything. That's why I like %add. So this is just the basic code. This is a procedure. And now we have some magic command here in the end, which is called Excel command register. And this command register allows us to register a skill procedure, myPP, with a Allego PCB editor console command. I call it now pp_rep, right? So click and place report. Now, by this, once I have done this, I can enter this command here in the standard PCB editor command line. So let's load this code here, load pp.il. This is the name of the file, which is in the same local directory. And now I can here enter the command my_report, and I will get, or my pp was it? What did I have? Sorry, no. pp rep place, not my pp report. Click and place _report. And now I'm getting such a report. This is the way how you can start, or how can start coding with skill, right? And this is all about FloWare. We do not have any other additional capabilities we do not use, except when it comes to providing or to shipping code, doing some kind of encryption and things like that. Here you would need an additional license, but the actual code, you can do exactly the same thing. We are not in a better position like any other, like our customers. We're in the same situation. So even with all the capabilities provided in Skill, you can create your own pull-down menu entry. You can create your own command and the temper mesh can create options panels. There's nothing special, right? Okay, so let's start now with the first application. I would like to start with the anti-temper. So I'm just checking time. Oh, it's half an hour. That's great. That's so let's start with this one here. And this is now our spectacular, a very simple PCB. I will then jump into a more, or in the larger database. But just to start, say this is our board. Here's a cutout. Here's our IP. It might be a flash. It might be a DSP or whatever with sensitive information. If you want to prevent that anybody is trying to temper this this board here by opening the chassis and looking, okay, how can I read the encryption keys from this device here, right? So we go to FloWare, edit, anti-temper, and one of the first steps you have to do is you have to select the region you want where you want to generate the mesh. So always use the right mouse button, the context menu. Select region, and now you're picking this region here, and it will generate now a mesh cell. So, so you can specify now the line width to be. So number of signals are 3. So that means I would like to define 3 signal loops. And as soon as I adjust now the track width and the track spacing, 0.2, 0.2, and additional clearance to any objects, 0.2. Is the mesh or the cell. So the grid cells will be regenerated. You can specify the origin. Right now we are in the lower left region. We may also go to upper left, and then it will get regenerated. But we are fine with lower left. And of course, it's quite obvious. Whenever we generate now some traces, all cells or each cell which covers a design outline, which covers any keep out or cut out, or which touches any edge-related objects with a given distance, they have to be disabled by default. You can do that manually. You can say, oh, clear cells manually. But this is time-consuming. So rather than this, we use a check region overlap. That means everything that is now intersecting with a selected region will be disabled automatically. We can say check keep-out. I'm clicking on this keep-out here. They will be disabled. We can specify to use check edge. I'm clicking now all edge or cells where an additional clearance of 0.2 millimeters required will be disabled as well. And as I mentioned, you can say, okay, I want to, for some reason, I would like to disable these cells here as well. And next one is you specify the starting point, right? Select starting edge. You say, I want to start here. And then all you have to do is simply press calculate mesh, and then it will get generated, the signals, right? Now I'm fine. I'm now routing the nets. For example, this one here is still not connected. And now you see that the 3 signal loops have been connected properly. And this is now display element. I'm going now selecting now nets. You will see now this is now one net, right? And it's covering now the whole signal loop has been generated. It's covering the whole board. And you can follow the trace, right? So, and all the monitoring is then done, of course, here somehow internal in the device. So you may argue, yes, this is a really simple example. Everybody can do this. Let's do it on a larger board. We open that one here, and now this is I think it's 20 inches long or 10 inches. I don't know exactly, but it's a huge board, and we want to do the same thing. Here's our sensitive device where we want to generate from which the signals originate. So we launch it, FloWare, edit, anti-tamper mesh PCB. So same procedure. I'm fine with line with 10 mil, 10 mil, 10 mil additional clearance. I'm selecting now this region. Grid cells are getting generated. Next step is check region overlap. All these cells here slightly covering the selected region outline will be disabled. Now, of course, we want to check with respect to all edge objects. This may take a couple of seconds. So because here, whenever there's some copper, no data will be generated or must be generated. So now we are done, and you can see here. But all the remaining cells which are still open will now be processed by the applications. Where do we start? Right mouse button, select starting edge. We want to start here. And now we press calculate. So we may now start routing from here. Finishing the and now we can see there's one big signal. Right? Display element, that one, and this one is about 1,000 inches long. So it can even also used by huge boards, by big boards. Trace mesh generation for anti-tamper purposes. Okay. Next one is AOI. So as you can see here in this design, we have some small components, thin components with some tall components. There is a transformer, there's some fuses, there's some big bulk electrolyte capacitors, and during reflow process or during AOI process, it might happen that such a tall component may generate a shadow and shadow this pad here away from capacitor 1 or being or leading to the situation that the camera cannot properly check whether this pad here has been properly soldered or not, right? And how do we do so during floor planning phase? So we launch the application, edit, check review, sorry, AOI checking, and I turn off general shadow areas, right? Just just to start with the application. So we can specify the camera angle, the direction, and then we say run, AOI checking. And as we can see here, yes, there's some DRC. this DRC for pad C1 is probably caused by a shadow that was generated by component C3, right? Yeah, and such a similar check is already available in Constraint Manager in the DFA domain, but this one doesn't allow you to show you the shadow areas, right? And it it is not that flexible in terms of in which direction you want to generate the shadow. So let's turn on the shadow area checkbox, which is on by default. I have just turned it on for explanation purposes. So run again and say AY 2D. And now you see, okay, C3, based on its height and based on the camera angle, it will generate such a shadow. That means if now any other components, like the component C1, a pad is now intersecting with this shadow, it will generate a DRC. Of course, C1 has also its a certain height, and itself may generate shadows for other components. That's why you will also see a shadow here. But for the check, for the DRC checking here, it's quite obvious that this DRC is caused by the shadow from C3, right? So what does it mean now? How can we impact the shadow? So C3 has a big shadow around its component. U100, U501 has a small shadow generated around its outline just because it's thinner, right? And yeah, this is one parameter, the component height. The second one is the camera angle. By default, it's 90 degrees. If we go to 10 degrees, for example, and we regenerate, we realize that the shadow becomes smaller, right? So, but what about the direction? As I mentioned, the shadow will be generated in all direction. You may specify to horizontal, taking account the conveyor belt direction. Right? It will generate a DRC, or you may decide if the direction is vertical for some reason, we don't know, something you may discuss. The shadows will be generated in the vertical direction. You can also specify angles. So horizontal, you can say, I just want to generate a shadow like with 45 degrees or with 45 and, I don't know, 215. To the left and to the right. So lower left and upper right, right? So this is possible. So usually, I guess in most cases, you will use the as the all direction. Yeah. So some more capabilities are provided in the tool, especially when it comes to 3D additional 3D requirements, which account for special some scaling with respect to the conveyor belt direction. This was driven by one big automotive customer who is heavily using this application for high volume productions. You may wonder, or you may argue, why does T1 not generate? It's a transformer. Why is it not generating any shadows? This is just because this component here will be manually assembled in the end. So there's no need to generate or to check this with respect to shadows, or vice versa. If not somehow disabled, it would generate redundant DRCs or false DRCs, which should be avoided. And this can be controlled through properties. So you can attach a property, AY ignore shadow, to those components which need to be, which will be assembled in the end, or which need to be excluded somehow from shadows being generated. And also you can do this for the target objects. For example, if you have, for some reason, any test points and you want to avoid false DRCs, you can specify also certain footprints to be excluded from DRC checking. So this is AOI, very powerful applications for AOI checking DRC upfront during the floor planning phase. Okay, next one is contour placement. Yeah, application is fairly simple. You go to FloWare Edit, Contour Place, and now it's fully, let's say, options panel driven. It's an interactive application. And the first step you need to do, if you just try it out, you may wonder, oh, how do I work? So you do not you need to specify to select the active contour you would like to act on. So this has to be the first operation you have to do, or the, say pick active contour. I'm picking this line here, along which I now want to place my components. And now have selected one. I go to place. I'm picking such a component here, and as you can see here, it's sufficient to place nearby, to pick nearby, and components will be properly aligned using the log long side argument. And if I choose short side, it will align in a way like this. Alternatively, I can choose place and spin, click here and say, and now adjust the rotation as I'm used to with the regular spin command. Or I can also I only want to spin at a given location. This is possible. So now, when it comes to, as you can see here, what I've done, I've simply clicked somewhere on the path, and the nearest point on that path has been calculated. You can also specify those point snap markers manually using the marker manual command. Click here, click here, click here. This is one. Or alternatively, use the marker equidistance. You specify a distance, for example, 4 millimeters, quantity 5. You click somewhere, and now you can say click plus, 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 minus, 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 or you increase the value. The distance I get regenerated until you left click, say plus, 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 and now I'm committing these snap points, and now I can go into I can pick again my command, for example, log short side, click somewhere in this intersection to my snap marker, and it will of course then use the appropriate snap point properly. If you plan to create your path from existing contour, you can do so by, for example, here you have a shape, and we would like to place now our components along this circle here, right, or along this outline. We can choose create contour from object, click on this one here. Now we have created a contour, and now we can decide, okay, which one do we want to act on? Say, for example, on this one here. This is the one we would like to act on. We go to marker equidistance. I don't know. We specify 5 markers. Click here. Now these are our snap points. Left click to confirm. Now go to place. Pick a component, attach it to cursor, place nearby, and now click nearby, and you can see now how the application now probably snaps to that contour placement. Okay, next one is our digital solder mask. Here we need to explain a few things up front. So first thing is, as I mentioned, we may need multiple layers on which we create solder masks in an additive way. So first thing we have to do is we define those layers in the cross-section, or they should be available. Actually, then it's not mandatory. You can even do that without, but for visualization purposes in 3D, it's useful to define those layers in the cross-section. So you have defined digital solder 1 top, 2 top, 3 top, and also for the bottom side respectively, with a given thickness. And they are just now candidates where we can generate additive solder masks. Now we launch the application. We go to FloWare Edit Digital Solder Mask, and we can enable now those layers on which we want to generate the solder mask. And then we take a look at the rule sets first. So what kind of solder mask operations, while creating, while picking an object, while selecting a zone, while defining a region, what are the shapes of solder masks, or the types of solder mask objects that can be generated? The first one is a component mask. Component mask means, okay, based on the component boundary, which is by default place bound, we will generate a mask when a given component is selected. And we will void the pins, we void vias respectively by specifying the parameters, can specify some additional margins and min-apertures in order to make them compliant. And and then we have defined those rules. These data, what we define here, is completely ANI driven. So you can configure that in the installations or in the sites. That means whenever you open a new board, all the existing parameters will be leveraged and will be read into the tool. So, CDS site compare or compliance or aware. Sorry. Next one is, for example, the pad ring rule. How do we want to generate pad ring if required? We may want to specify how a pad entry rule looks like. Okay, what about the width of this solder mask trace? Actually, it's a trace in the perpendicular direction of the signal trace. How large shall the gap be between pins and vias, and so forth. What about an edge oversize? For example, here, when you select a trace or if you select a shape, you may want to oversize this with a given amount, just in order to provide additional isolation, right? So this one here is called edge oversize 100 micron, which simply oversizes with 100 microns. There's a second one, which oversizes 200 microns. So this is just a rule set. This you also have, let's say, a region rule where you can specify, okay, what happens if I simply select a region, define a region by window drag. And now, in the general tab, I'm using now actual, I'm specifying now what kind of data when I'm doing now interactive operations, such as I'm selecting a component, I'm selecting a region, I'm selecting a zone, what do we want to process? So we start with a component mask set and always read from left to right. So that means if a component is on the top edge layer, right, we generate data on solder one top, and we use the component rule 1. If multiple rules are available, you could pick them from the appropriate by selecting them from the drop down. Same applies to component on the bottom, right? And we do so now, and we say, okay, right mouse button, select symbols. I'm clicking this symbol here. I'm clicking this symbol here, and now we can see how easy it is to generate now component solder mask, right? It's an additive technique, right? It's only defined where really needed. Delete everything, of course. You can also say pick zone. This one is zone driven, and say, oh, process all components within that zone, as an example, and it will process the components accordingly, right? We may continue, or alternatively, we may use a pad ring MSet or mask set. So components or pads on top layer will generate data on a solder 1 top using the pad ring rule 1 in this case here. Again, I can select pins, or I can select pins like this one here, click here, click here, click here, click here, delete all, or then in a similar way, pick zone, click here, and now all the pins within that zone have been selected and a pad ring will get generated. Or use the pad entry mask set. It's a bit more complicated to calculate. Pad entry rule, like this one here, but this is the one we want to process now. Again, choose pick zone, click here, and now you can see how any trace entering now a pad will get an additional solder mask bridge or get generated perpendicular to the direction of the trace, following the contour of the pad. And the parameters, the length and the width can be specified, of course. So we may try now pad entries. Rule set is now using a rule, pad entry rule. Go to the rule set. Pad entry will give a length offset of 0.3 millimeter. We are not that happy with 0.3. We want to 0.2. We want to use 0.3. Delete all. Process again, and now the length or the segment has become a little bit longer. So what about additional isolation? This is useful. So let's take a look at this one here. Pad entry 2 layers, or edge MSet 2 layers. What does it mean? Selecting a trace on layer top will generate data on solder 1 top with an oversize of 100 micron. with 200 microns, sorry. And selecting data again on top layer will generate another solder mask on solder 2 using an oversize of 100 micron. So this is now the ability to provide better isolation, increase the the final solder mask thickness. And what we can do is right mouse when we simply say, okay, in this case here, I would like to select edge only, selecting these edges here, and now we can see how 2 shapes have been generated. Now let's take a look at this in 3D. We go to View 3D Canvas, and we'll clearly see set up preferences, use design colors. Yeah. Yeah, here we go. Now you see 2 solder masks. Following the traces, it may not be necessary to apply a smaller oversize for the second one. This is just for clarification purposes. But this is something that is also needed when it comes to additive techniques, provide better isolation. One layer is usually not sufficient in terms of its, and the thickness cannot be changed so easy. Usually it's about 50 or 20 micron. Okay, so that's digital solder mask. Remember, think positive. This is the main idea behind this application. Net min gap. Let's start with this one here. Now we want to measure. We go to FloWare, edit, go to net min gap. Where is it? Check review. Excuse me, there are so many applications. Net min gap. So simply select a few thickness and measure against each other. We want to measure on outer layers only, or report only the end smallest gap of 1. Simply select run. It's quite obvious. When I do a selection like here, C, E, and P is selected on both sides. Of course, the application will silently ignore. It will not measure nets against itself. It will measure all nets against from group A on the left with all nets on the right, but excluding any same net combination. Of course, this is trivial. Doesn't make sense. Of course, you can do some filtering here using wildcards. You may even now select classes, right, and say, okay, I just want to measure these nets here against these nets here. This is possible, and so simply let it run. There's also a way of now cross-probing the distances, the results. You can even color them. Click on them again, and now you will see that the nets will be colored accordingly. Color A, color B for the first nets, for the second nets to be measured against, and now you will see exactly where the smallest distance is. Now, some more advanced stuff. You can go into the class select mode, and here it allows you to measure now classes against classes. So we want to measure AC power against DC power. We don't care. I just want to report or to measure all the combinations against each other. And now you will see the different combinations. But an alternative requirement might be that you say, I am just interested in the smallest distance. No matter which of the two, which nets are involved, just give me between AC power and DC power the smallest distance. So that means under the hood, the nets will be merged somehow virtually. Say run, and then you will realize that there's only one smallest distance. And the benefit is that now the complete class is highlighted with all the nets, but the smallest distance can be found here. It is between 3.3 volt and L1. So there are some options available here. You may even select merge classes. So if you have selected multiple classes, please report, for example, AC power, DC power, G and D class versus three-phase. From all selected classes, give me the smallest distance to a net of three-phase, right? So merge classes, and there will be only one difference exactly as this location here, right? This is maybe useful for review purposes. So I think I still need 5 minutes to go. I hope this is okay. I would like to show you variant assembly improvement. This is variant assembly here. Let's launch the application. Manufacture. No, it's documentation. Sorry. So where's the new feature? The new feature is here. So specifies the scale to be used, 1.5, for example. Now, yes, we would like to mirror the bottom view in order to improve readability. And now we can say, right mouse button, reposition top view, reposition bottom view. And now, as usual, generate the data. For example, for variant Asia, generate the data. You may decide to modify the color. For DNI components, you may want to decide remove label only or cross label only, or cross graphics in a way like this. Yeah, that's the way. Here the application behaves as usual. There are some other improvements have been made here, component secondary. So this is next. Now we also have provides the ability to distinguish between SMT and DHT components. So this applies in situations where customer use different subclasses for the package geometry boundary for SMT and DHT component. So, but all the existing functionalities that exist so far is still retained and still available. For example, if you plan to annotate the value to the drawing as well. So this is variant assembly. And last but not least, I would like to show you the significant improvements we have made in the penalization application. This is one here. So as you can see here, customers have often tried to launch penalization from here, by launching it from an existing database, which is obvious, but the application was always blocking this operation so far. You are getting now the information that a panel starter base must not contain any logic. It has to contain only design outline and rootkit in, and nothing else. But now you are asked, do you want to create a new panel from existing database? And now you may say yes, and you can specify the panel setup, for example, panel width and panel height, edge clearance. So it means in that case here we want to create a new one, or by selecting a template. So which one shall I try? We can try both. So let's try with this one here first, completely from scratch. New panel 610 by 457. Additional edge clearance, which applies to the distance between the rootkit in to the design outline. A design outline can be specified, and we will also import the technology from the current layout into the panel starter database. Say great. Technology will be written, will be exported. Now setup has been already prepared for you. The only thing you need to do right now is create modules and simply place the boards. 1, 2, 3, 4, 5, 6. And now it's a regular panel database as usual. Alternatively, I'm opening the single layout again. FloWare, manufacturing penalization, say select the template, and there is a configuration directory, which is of course HideAware, where you can store all your panel starter databases containing some additional fiducials and dimensions and things like that, and mounting holes, whatever you need. Pick that template and proceed in a similar way. Click create, override, and now we'll create a new database as the current working directory. Application starts again in a similar way. Again, create modules, place 1, 2, 3, 4, 5, 6. And your panel is ready to go. So that's so far. Yeah, I'm finished now with the demo part.
Thank you. I think everyone forgive us for going a little overboard. What a great overview of some of our FloWare modules. We have seen that a lot can be realized with skill, and perhaps we have now inspired one or the other to program something on their own. Are there any resources that you can or we can recommend for learning skill?
Yeah, so as I mentioned, resources are already available inside the installation. I'm referring to the function folder. And of course, also including the documentation. There's a skill reference guide, there's a skill user guides, but it's also, if you're a cost account, if you're a maintenance, a skill training. As far as I know, it's even, it doesn't say for free. There's a skill online training available.
Perfect, wonderful. And maybe if we take only just short time, would you like to give us a little insight? How is a FloWare module created?
So usually based on discussions, on challenging discussions. When I say challenging, I mean, okay, if a customer is asking for something, I'm getting a bit picky and I say, okay, please, exactly what do you want to have? How should the application look like? How should it behave like? What kind of information do you provide up front in order to run it? What kind of information do you want to enter in an interactive way or by using, I don't know, configuration? So there are a lot of things a few questions to be answered. And then, as I mentioned, we're taking the initiative and we provide, or we generate, we program a prototype, and then we show to the customer. And then, due to the fact that I have been a bit picky up front, usually the customers are then happy, right? So because it's necessary to provide a clear specification, right?
Yeah.
And yeah, but of course, so just. It is also possible if a customer is asking for just a very specific feature, only a specific customization, only for his own needs, for his specific needs. This is also possible. Then we say yes to everything. Just an example, I want to have a pink button. If a customer is asking for a pink button, he will get a pink button.
Wonderful. Okay.
But usually not every. Usually other customers do not want to have a pink button.
Yeah, that's right. Okay, so and can we have some outlook? Is there currently something under development? Can you give us some information, or is all not ready set?
So at the moment we have just thinking about adding some more enhancement to existing modules, but I cannot give any details here because we need to align our, let's say, our release schedules a little bit. That's still internal. No.
Okay.
In general, there are some applications we're thinking about, like step up paste. I don't know the step up pencils handling. That's something that we may work on in the near future, right?
Okay.
So because there are boards which require, let's say, partial or different solder paste thicknesses in different regions, and this has to be handled also somehow. At the moment, there's no process built into PCB editors. This is fully driven by the PCB manufacturer. Here we want to add some more control, but it's really early at that time. Here we do not have any prototype yet running.
So any news will follow. Okay, thank you. So if no one has any questions, but please, if you have questions or if you have an idea for a FloWare module, please call us or send us a message. And thank you for your interest. Have a great day and see you next time.
Bye-bye.